Hi, I'm Teacher Thomas. Welcome to math class. Today's topic is integration, improper integrals. We face improper integrals in one of two scenarios. One is when we have a limit that is either infinity or negative infinity, as in our problem number 1. The other is when we have either one of the limits or in the range between the limits, a scenario in which the integral is not valid, as in the case of number 2. When we put 0 into the denominator, we end up with a fraction with a denominator of 0, which is not valid. So we'll look at both of these scenarios, following the requirement, find the value, if it exists, of first number 1, the integral from negative infinity to negative 2 of 10 over x cubed with respect to x, and number 2, the integral from 0 to 9 of 12 over x squared times square root of x with respect to x. Beginning with number 1, I'll first rewrite this expression as a limit. The limit as c approaches negative infinity of the integral from c, notice I'm replacing negative infinity with c, to negative 2 of 10 times x to the power of negative 3 with respect to x. Continuing to work with a limit as c approaches negative infinity, and now I'm going to integrate 10x, increasing my exponent by 1, to negative 2, dividing by the new exponent of negative 2, with an interval from c to negative 2. Now I'll substitute in the lower and upper limits. Limit as c approaches negative infinity of 10 times negative 2 to the power of negative 2 over negative 2 minus 10 times c to the power of negative 2 over negative 2. Continuing to work with my limits, I'm going to simplify my expression. My first term will simplify to negative 10 over 8. Oh, I also need to add in brackets right here, otherwise I would have the incorrect value. So now with the correct notation, my second term is negative 10 over negative 2 is plus 5. C to the power of negative 2 is in the denominator, c to the power of 2. Now I will write that as c approaches negative infinity, 5 over c squared approaches 0. When we replace c with negative infinity, we end up with a very small number. A very large denominator produces a very small value approaching 0. And now we can simplify, no longer using a limit. We've now factored in the limit to negative 10 over 8 plus 0, replacing 5 over c squared with 0. Our final answer, negative 5 over 4. Number 2, I'll create a limit. This expression equals the limit as c approaches 0 of the integral from c, using c to replace 0, to 9, 12 times x to the power of negative 5 over 2 with respect to x. Now integrating, the limit as c approaches 0 of 12 times x to the power of negative 3 over 2, dividing by the new exponent, negative 3 over 2. The interval is from c to 9. Now we'll substitute in our limits. Limit as c approaches 0 of the quantity 12 times 9 to the power of negative 3 over 2 divided by negative 3 over 2 minus 12 times c to the power of negative 3 over 2 divided by negative 3 over 2. Here I will simplify the limit as c approaches 0 of 12 divided by negative 3 over 2 is negative 24 over 3. So that resolves the 12 and the negative 3 over 2 times 9 to the power of negative 3 over 2 is times 1 over 9 to the power of 3 over 2, which is 27, minus 12 over negative 3 over 2, again, is negative 24 over 3, times c to the power of negative 3 over 2 is 1 over c to the power of 3 over 2. I'll make a couple more simplifications right here in the same line. Negative 24 over 3 is negative 8. And negative 24 over 3, I have minus negative 24 over 3. So this is going to be plus 8. Now, evaluating the limit. As c approaches 0, the value of 8 times 1 over c to the power of 3 over 2 approaches infinity. As c gets smaller, 1 over c to the power of 3 over 2 becomes a larger and larger and larger number. The fact that we're multiplying by 8 is not significant. This number approaches infinity. Thus, limit does not exist. This completes our requirements, and this completes the lesson on integration, improper integrals.